Hi everybody. So for this module's discussion, I decided to look at some data that was posted on the icon page about our class specifically. And as you can see the table over here, this is the section that I chose from it. I decided to just look at the first 20 students, the data that they brought to the table, just so it was a smaller data set and it'd be easier to analyze just for this purpose. And I decided to specifically look at the results of the Module 1 quiz. So as you can see, I went ahead and I copied the data right here onto a table, just copied the exact same way. And in order to make a table from that, I selected all the data. We're going to click on Insert and then Recommended Charts. And we're going to go down to the second chart right here, which is a histogram. And this specific chart is going to be better for this data set because this data is quantitative and it's on a high to low scale. The high being, the highest points you can score on a test or a quiz, and then the low being the lowest points that were scored. And so this is just going to be a much easier way to analyze the data back and forth. See the separate student scores since they're not part of the same being. And we're going to click on OK and go ahead and put that graph here. We're going to move it right below the table so it's easier to see. And as you can see, this graph is a little bit on the clunky side. A little hard to exactly discern, kind of what's going on. So in order to make it more clear, I decided for the second graph for this specific discussion, I made this table over here. And I decided to look at the specific quiz grade and analyze how many students received which grade. And so this is going to be an easier way to look at the layout of how many students received what grade and what the average grades were along the spectrum. So one important thing to look at when doing this kind of thing is the quiz grades. The quizzes were out of 10 points. And so the 10 point here is the highest. So for the percentage, as I have stated over here, all you're going to do is times the quiz grade by 10. It's just going to be a much easier way of looking at it than with all the decimal points. And one thing that you do specifically is make sure that the number of students over here adds up to the number of students here, which is 20. And just to double check, we have 2, 7, 10, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we do have all the students represented here in this data set. So what we're going to do the same thing. We're going to highlight all the information, go to Insert, Recommended Charts, and since this is the same basic data formation, we're looking at it on a high to low scale. It's quantitative, straight numbers that don't change, aren't rounded. So we're going to go ahead and click on a histogram here. And you can tell this is a histogram because of the separated columns, as I'm pointing out with my mouse right now. I'm going to click on OK and put that graph in our set right here. And now that we have the graphs kind of side by side, you can see they're much easier to compare and look at it this way. They both show different information. This shows the basic students, the fluctuations, and this shows the percentages of the whole class and how they add up together as an entity of a classroom. And one way to help us view this better is by looking at the descriptive statistics. So for the first graph that we have here, the range is going to be from the lowest number of questions correct to the highest number. This gives us a view of what kind of data ranges we're looking at. And as we can see on the graph here, our lowest point is a value of 4, and our highest is going to be up here at a value of 10. So 10 minus 4 is going to be 6, so our range is going to be a value of 6 questions correct. And now for our medium, it's kind of hard to guess it from this graph, so we're going to go right up to the table. And as you see in this line over here, I have separated the same information that's in this part of the table here, but I've just ordered it from highest to lowest, which is going to be much easier to find a median this way. And since it's separated and organized like this, all we have to do is look at the middle of the data. Since there's 20 students, 20 divided by 2 is 10. And so we're going to separate the students into two groups of 10. right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 students, and then 10 students below that aren't highlighted. And for the median value, we're going to look in between those. So the median is going to be between 8 and 8.5. So we're just going to put it down as an 8.25 for our median there. And quartiles, we can do by looking at the median. So if we look at our separation right here, all we have to do to find quartiles is to separate this amount into half again. So we're going to do 10 divided by 2 is 5, so each quartile is going to contain the information of 5 students. So I'll highlight one quartile here. We have 1, 2, 3, 4, 5 students. So right here, this is the first quartile. This right here is going to be the second quartile. This the third. And this the last. So our interquartile range is going to be a value of 5 students. Now we're going to do the standard deviations for both together because it's more of a complicated thing. So we're going to look at the range here of this table specifically. You can see our lowest value for the percentages is going to be 1 student. Our lowest value is going to be 0 students because there weren't any here. So that is our lowest value. And then our highest is up here at 5 students in one bin. So 5 minus 0 is 5. And so our range is going to be 5. All right. And for the median here, we're just going to be counting back. So we're going to mark 1 off here and 1 off here. So for the median, since there's 20 students, since we have them in kind of a linear order, it's going to be much easier to do it on the graph. Since there's 20 students, again, we want 10 students in each bin. So we're going to count 10 students. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you see one bin is going, or one half of the group is going to be over here on this side, and then the other half is going to be here. So our median is going to be right in between these points at 82.5%. And there we go. And the same thing that we're going to do for our quartiles is we're going to separate, since there's 10 students in each half, right? We're going to separate it again, and 10 divided by 2 is 5. So there's going to be 5 students in each quartile, because 5 plus 5 is 10, plus 5 for the third quartile is 15, plus 5 of the fourth quartile is 20. So it adds up to our total of 20. So just to show an example, we have 1, 2, 3, 4, 5. So the first quartile of students is going to be in this group right here. Then we have 1, 2, 3, 4, 5. And our second quartile is going to end here. 1, 2, 3, 4, 5. Our third quartile, I'm circling here. And 1, 2, 3, 4, 5. Our last quartile right over here. Just to give you kind of a view. And so our interquartile range, again, is going to be 5 students per thing. All right, and now we're going to move on to standard deviation. And I'm going to move over here to some tables that I have separated. And as you can see, this is the same data table from over here. And the first step to finding the standard deviation is we're going to find the mean, which is the average. So what we do is we add up all of the values on this side here and divide it by how many we have, by how many total. And so we have 20 values, so we're going to add all of these up and divide them by 20. And the answer that we're going to get here is a total of 7.6. And with that number, the 7.6, we're going to find the difference between each of these individual values and the mean to show us how far each specific student was away from the average, which is going to show us how descriptive the average actually is of the group. Because when you hear the word average, you think, okay, then that's going to describe the average student, but we're going to see how far away the actual student actually is from the average. And right here we have that, and I'll show you just kind of the math that I did. We have 4 minus 7.6, we're going to get a negative 3.1. And then right over here, 5.5 minus 7.6 is going to result in a negative 2.1. And then on the other side here, you have like 10 minus 7.6 is going to be a 2.4. And we did that all throughout the table here. And once we have all of those values, we are going to square them. So we're going to times them by themselves, and I have that math done right over here. It's really nice in Excel because you can do specific formulas however you need, and so it's really easy. Just snap in a formula and you'll get all of these answers without having to manually do them. Alright, so we have the squared values right here in this column. And then this bottom number right here is the next step. We're going to add all of these together. So the average amount that people are apart from the mean is going to be squared, obviously, is going to be 54.1. And then we're going to divide those by the amount of values to find the average of this, which is 2.75. And right here, we squared all of the numbers. And so now we're going to find the square root of this to find the average amount that each specific student is away from the mean, which is going to be 1.644. This is the standard deviation right here, and this is what this is saying is that each student of the first 20 students in our data set and our sample size is on average 1.6 questions correct away from the average grade. And as you can tell, this is kind of a big number, so this shows that the results are more skewed, they're more separate from each other, they're not as clumped and as clustered as they could be, so the average may not be as representable to the average student. It may not actually represent what it is. And if we move down here, we can see the exact same thing, but just for the second graph, which you can view on this side of the screen. So we have all of our values here. Our original graph just copied exactly from what we have here. And so what we did is we're going to add up the amount of students for each. We're going to find the average, or the mean, which is a 2.69 students. So that means on average, 2.69 students are scoring per a certain grade. And so we're going to do the same thing that we did over here. If you remember, we're going to minus the average and find out how far apart these results are from the average that we received. And so you can see I wrote out all of the math here so it's easier for you guys to see what my exact math is. And then we have the answers right here. So 2.269 minus 2.269, sorry, is going to be negative 269. So that just shows how far apart the actual results are from the average. And as we move over here, the next step, if you remember, is we're going to square all of those, right? So we're going to negative 1.69 times negative 1.69 is this. And we did this all across the board right here until our next step when we add all of those together. And if we add all of these numbers up, we're going to end up with 45.7093. And since we squared the numbers here, we're going to need to, first we're going to find the average, right? So we're going to look at, we had 13 total bins right here. So we're going to divide 13 by this number, which is 3.51, and since we squared right here, as I was saying earlier, we're going to find the square root of this number and end up with 1.873499, which is a big number, so we're going to round that to 1.9. So as you can see, on average, 1.9 is how far away students are from the average on this specific data set. So these are fairly similar, but they are a little bit off because of the different data that we used for each of them, the different data organization. And so what these graphs and what these numbers can tell you is actually important. It actually gives you a lot of information. The numbers allow you to see how accurate and truthful and what the data actually means. The graphs are a good way to visualize the data that you see. This visualizes every student's grade. So this is a good way to see, okay, these is what all of my students are scoring. And right here you can see the percentages. As a professor or as somebody looking in on the class, this is a good skew to have. You're going to want to have most of the students in the high point, you're going to want to have them closer to the 100% mark than closer to down here. So this kind of shows how the class is doing, how the instructing and everything is going, and this bodes well for the class. And also, this data over here and the standard deviation is going to show us how representative the sample size and the data is of the actual results. Well, thank you for listening to my talk, and I hope you learned a lot. Thank you.